So before we move on and talk about some other methods, let's expand the net present value method a little bit. Okay. First, let's look at total cost approach. We'll just compute the net present value for two things and choose the best thing. That's all we're looking at. So here's an example. We got two choices. We can remodel or we can build new. All right. We have to pick a discount rate, maybe based on our cost of capital, maybe based on something else we can invest in, but in this case we've chosen 10%. All right. So we got some revenues, we got costs, and we got cash flows. All right, so 70 minus 25 is 45, 90 minus 30 is 60. So here's what we need to think about discounting right there, our net cash flow. All right, so if we install a new washer, 3,000 is going to go out. We can use it over 10 years. At the end, we can get some cash flow in of 7,000. We'll have a little more cash flow out. And we replace the brushes. And then we would be getting rid of the old stuff. So we'd have an immediate cash flow in of the old stuff. All right, so let's look at this. So here's your initial investment. Of course, no discount because this is today. We cash flow out of 300. Replace the brushes in year 6, so you'd have to look up year 6 at 10%, and you get this factor. So we'll have this cash flow out of 50,000, but its net present value is 28.2. Then we get this annuity. Every year for 10 years, we get a net cash flow of 60. Right? Remember, we're going with the net cash flow. We're not going to discount the costs and the revenues. Okay, so when you go to the present value of an annuity table at year 10, so you go down to 10 and then over to 10%, you get a factor of 6.145. So 60,000 times 6.145 gives us a present value of the cash flows, 368.7. If we're going to put in new equipment, we're going to sell the old equipment. So that's now, so that's no discount. So we're going to get 40,000 immediate. In 10 years, when we're done, we'll sell the old equipment for 7,000. So look up 10%, get a discount rate of 3.386. So that means that 7,000 is worth 27.02 today. You add up all your cash flows, the net present value of getting a new one is 83,202. Let's look at the cash flows for keeping that. So as we recall, we're going to have a cash flow of 45,000 from the old car wash. Well, we'd have to remodel it. We don't have to buy a new one, but we have to remodel it. And then in 6 years, we'll replace the brushes again. So we have a couple of cash flows out. So our cash flow out with no discount, 175. Our cash flow out in year 6. So year 6, we find the year 6 line and go up the 10% column, and their discount rate in year 6 is 0.564. So 0.564 times 80 is cash flow 45,120 in today's dollars. And go to your present value of an annuity table, 10 years at 10%, and come up with 6.145. So 45,000. Your net cash flow is equal to 276,525. So here's our NPV for just replacing stuff, repairing it, and keeping the old one. So we got two NPVs now. Which one do we like better? Well, new washer, 83,202. Old washer, 56,405. So if we put the new one in, we're going to be better off by 26,797. So I guess we get a new washer. Now, sometimes you don't have a cash flow in, right? You're just deciding what's going to have the least cost. And of course, if it's cost you're spending over years, you want to look at that from a present value company. So here's another one of these choices: overhaul or buy new. Very, very frequent choice. And our discount rate is 10%. So I'm sure we're going to have some costs with these. So here's the information. The overhaul for the old truck is going to cost $4,500. Costs us $10,000 to run that old truck. Maybe it's going to get as good a gas mileage as the new one, stuff like that. In 5 years, the old truck will be worth $250. When I sell it now, if I decide to buy a new one, I can sell that old truck now for $9,000. Now, if I buy a new one, it's going to cost me $21,000. It costs me less to operate. It's a newer truck, maybe gets better gas mileage, stuff like that. And 5 years from now, when I sell it, I will get $3,000. So let's compare these two. All right, new truck cash flows, right? So the purchase price, that's just $21,000. Operating costs, $6,000. I will get the salvage value of the new cost of the old truck, because if I buy the new truck, I'm selling the old truck, and that's a present, so there's no discounting. So $9,000 cash coming in, and 5 years from now, when I get $3,000 cash flow in for the old truck, 5 years at 10%, look that up on the table, you'll come up with 0.621, so 1863. So 21,000 minus 22,746 plus 9 plus 18 means the new truck is going to cost me, in terms of present value, $32,833. Old truck, if I keep the old truck, present value of the overhaul is $4,500. Cash flow out, years 1 through 5. So I get my year 5 present value of an annuity at 10%, 3.791. 10,000 times 3.791 is 37,910. If 5 years from now I sell the old truck for $250, well, that's $155 in today's present value after the discount rate. And so I take 4,500 minus 37,910 plus 155, and the net present value of the old truck is minus 42,225. So the old truck is going to cost us 32,883. I mean, the new truck, if I buy a new truck, my total net present value of all my costs is 32,883. If I keep the old one, the net present value of all my costs is 42,255. So I'm better off by 93.72 if I buy the new truck. New truck. All right, so that's pretty easy. All right, next. Well, we've been talking about salvage values in 10 years, right? I mean, like with all depreciation, it's an estimate, right? So maybe we want to back into some of this stuff a different way and like, well, what would I need to get for a salvage value to make this work? And does that even seem realistic, right? It's like, I can't really foresee the future and tell exactly what it will be, but I can tell if I can get somewhere close to what I need to make this thing work, right? So let's talk about things that it's like, now with a contract, and you contract to get cash flow, like I'm going to sell you something for this amount. That's not what we're talking about. We're talking more about like that salvage value stuff. Like, I don't know. Let's do that. So let's look at that. So we got an example here with a super tanker. Everything's been estimated. So we know how this cash flow is going to go, but we don't know what the salvage value is. So we expect to use the thing for 20 years. But when we took all the cash flows we're going to make from this super tanker, how much it cost to build the thing, how much we're going to earn running it, and used our discount rate of 12. It came up with a negative cash flow at the present value. So the present value negative is 1.04 million, right about $1 million negative cash flow. But we haven't figured in what a super tanker is worth 20 years from now. I mean, there's a lot of steel in one of those things, right? What does it need to be? What would that salvage value need to be for me to do this deal? All right, so I know that without the salvage, it's a negative NPV. I don't want to do it. But what if I'm going to get enough salvage to cover that? It would be worth it. All right, so how do I figure it out? Well, I have to go get the present value factor and divide it into what I need, right? So I know I need $1,040,000 in today's value, right? But what I've got is a tanker 20 years from now at 12%. All right, so I take my 12 and I take my 20 and I go out to my NPV table and I get my rate of 0.104. Right, so I take what I need is $1,040,000. Am I going to get $1,040,000 divided by my NPV rate, and that ends up being exactly 10 million. So this right here is the amount I need that thing to be worth in 20 years. So what this tells you is if you've got something that's worth $10 million 20 years from now at a discount rate of 12%, today its net present value is $1,040,000. So we're just backing into this, right? Normally we've been discounting the cash flow, right? We'd say we have a salvage value of $10 million. What is that in today's value, right? And so we'd go find the present value factor and apply that. Well, this is the same thing, right? If I take 10 million times 0.104, I come up with 1,040,000, right? So this is just restating that, right? If I knew it was worth 10 million, if I was doing my cash flows, and I said, well, this thing's worth $10 million, and that's in 20 years at 12%. What's the rate? Well, 10.104. So take 0.104 times 10 million, and I would come up with this number, right? So we're just doing the opposite, right? We've done a little bit of simple algebra, and we said, I know that today I need it to be worth this, so I divide it by the 20-year 12% factor to find out what would that be in 20 years. So if I think that steel, if it's got $10 million worth of steel that can be broken up out of there, or I don't know what all they do, maybe, whatever else they sell out of it, I don't know. Or they sell it to somebody else who refurbishes it for 10, the super tankers are pretty big. That's a lot of steel. It would not surprise me if they were worth $10 million in the raw materials that you could get out of them. All right, so there you go. So you do something like that. So let's do the same thing again. Here's another example. So some architects are considering buying a drafting machine that would cost $100,000. It's going to last 4 years. Cash savings are $10,000 per year, right? Now, there'll be a lot of benefits to having this table that's just not something I can quantify, right? It's like the architects will be happy because they have this special machine and it makes their job easier. And they like new technology. It makes them happy and they keep working here. They don't quit, have to replace them. There's benefits, right? It makes us look good to clients because they see we have the newest technology. It's just, there's benefits, but we can't quantify them. All right, so if my actual benefits are the outflow cost is 100, right? The inflow in cash is 10,000, or cash savings, I guess I should say. What do I have to justify? What do I have to say? Well, is that really worth it or not? All right, so I take my cash flow out now, no discount, right? My net inflows, right, 10,000 times I go get my present value of an annuity, right, for 4 years at 14%. Ooh, that's a high rate, but that's okay. That's what our discount rate is for this architect firm. So I get that number. So now I've got to make up 70,860. but it's in present value, right? I don't have to make that all up now, right? I need to bring this net present value to this future value to today. So my intangible benefits, right? There's my factor. It's the 4-year 14% factor. And here's my gap. I've got a negative 7860 divided by 294. So this is what my intangibles need to be worth, right? 24,000 and some change. Is it worth that to keep everybody happy, impress the clients? Yeah, maybe it is, maybe it isn't. You'd have to figure that out. All right. So how do we rank investments in order of preference? Because some investments is like, I'm going to get the same return, but it's going to cost me more up front. You know, but how do I choose, right? Some of them it's a little not so obvious, right? So some it was easy. We did the 2 NPVs, and it's like, well, this has better NPV. What I choose that one, right? But let's check out some other choices, right? So we may want to rank things in terms of preference, right? So I may have so when we had NPV, we were like, this one has this NPV, this one has this, choose the higher. Or when we did IRR, hey, this got over the hurdle rate, great, we'll do it. But maybe we can only do, we have several things to choose from, we can only do one, something like that. So the higher internal rate of return, the more desirable the project, right? We get that. Net present value, and it's hard to compare unless the investments are equal. All right, so how do we do this, right? We can use a net present value divided by the investment. All right, so when you have two that have the same net present value, but different investments, what can you do? Well, you come up with this little profitability index, right? Take your NPV, divide it by the investment, and it'll give you profitability index. So for project A, we're going to get 1,000. We divide it by 10,000. Profitability is 0.10. For project B, we used to have the same net present value. Divide it by 5,000. We get a profitability index of 0.2. So 0.2 is better, right? If I can only do one, I'd pick that one. And finally, let's compute the simple rate of return for an investment. So not looking on cash flows, but rather net operating income. And it's just sort of like what we've kind of already talked about for rates of return, right? But when we were talking about rates of return in chapter, I guess it was 16, when we did the performance measures, we were basically talking about operating income. But when we're talking about a simple rate of return, we're talking about how that investment, it's part of the income, right? So in chapter 16, we talked about, you know, net income divided by all the assets, right? But it's the same idea, right? So we've got this initial investment in our asset, right? And we've got some operating income, so we can figure out a simple rate of return based on that. So here's a coffee bar wants to put a new espresso bar in. It's going to cost 140,000. Will last for 10 years. Incremental revenues of 100,000 and incremental expenses of 65, including depreciation. So what's the simple rate of return on the investment project? Well, net, right? So 100 minus 65 leaves us with 35, and it cost us 140, right? So our simple rate of return is 25%, right? That's pretty nice rate of return. So is it okay? Well, you're kind of ignoring the present value of $1. Well, you are ignoring it. So that was the whole thing with doing net present value was, yes, every year I'm going to get $35,000, but if I'm evaluating this today, that's not what 5 years from now is worth. So that, it's just going to depend on what you're getting. When investment center managers are evaluated using return on investments, a project's simple rate of return may cause them to bypass investment opportunities that have positive net present values. So you have to be careful about using ROI, and we've already talked about that as a performance measure back in, what was that? Chapter 11, I guess it was. So being careful. And of course, after project, you want to make sure you're actually realizing the results you thought you would. It's important to reassess and reevaluate your assumptions. And again, once something's a sunk cost, you might want to reevaluate it and see if you want to keep going forward with what you thought it was, right? So something to consider. Well, so that's it for chapter 14. Have a good one.